This is AQA GCSE Chemistry. It is a dual award and triple award topic, and it's atomic structure, and we're now on part 7. In this video, we are going to focus predominantly on ions and isotopes. I'm going to recommend that you pause on each activity as you go, and then you get a chance to find out what's going well and what might need to be developed a little further. So let's jump straight in with a couple of questions for you. And you can see here, carrying on from the previous video, we know that an atom is always a neutral charge. We also found out that protons have a charge of +1 and electrons have a charge of -1. So what does that tell us about the number of protons and electrons in an atom? And what we're looking for here is that the number of protons is equal to the number of electrons. Now, if we know that the number of protons is equal to the atomic number, we also know that the atomic number tells us the number of electrons in an atom. Why is it less easy to suggest how many neutrons there might be in an atom? Well, neutrons are neutral. Neutrons are also very unreactive. They don't really impact on any form of change. They weren't discovered until much later, as we heard in the history of the atom video earlier in this series. So we basically didn't know about them until much, much later on. Now for this task, I'm going to recommend that you try it. We have the model on the left-hand side and we have got the challenge on the right-hand side. And this is a very long-winded way of understanding why ions have the charge that they have. So pause it, have a read through, and then have a go at the questions on the right. So we're dealing with beryllium on the right-hand side. How many protons are there in a beryllium atom? There are 4 because it has an atomic number of 4. And how many electrons? There are also 4 because in an atom, the number of protons is equal to the number of electrons. Be really careful on these next questions. The total charge from the protons in a beryllium atom is +4. You've got to remember that protons have a charge of +1. If there are 4 of them, it's +4. In a similar way, what would the total charge from electrons in a beryllium atom be? That would be -4. Electrons have a charge of -1. There are 4 of them. That's -4. Now, if I've got a charge of +4 and a charge of -4, the overall charge in my atom of beryllium is going to be 0, the sum of those charges. Now we need to start to think about what happens in chemical reactions. And we look at this in the bonding topic in a lot more detail. But when atoms react, they end up with a full outer shell by losing, gaining, or sharing. In ions, it's about losing or gaining. What would be the easiest way for beryllium to get a full outer shell of electrons and become an ion? Well, it could lose 2 electrons because it's got 2 electrons in its outer shell. To get a full outer shell, alternatively, it would need to gain 6. So it loses 2 electrons. Now let's look at what that does to the atom that we previously had. It now has 2 electrons, and that means a total charge of -2. But it still has 4 protons, and that means a total charge from those of +4. You don't lose or gain protons in a chemical reaction. So what's my overall charge on a beryllium ion? Well, I've got my +4 and I've got my -2, giving me an overall charge of +2. And then how do we represent that? Well, we write out, as it's described here, the number as a superscript to the right of the element symbol. So I have Be +2. Let's have a go at exactly the same situation with potassium. So, how many protons are there in a potassium atom? There are 19. Straight from the periodic table, there are 19 electrons because in an atom, the numbers of protons and electrons are equal. So my total charge from 19 protons is +19, and from 19 electrons is -19, proving that in the atom, the overall charge is 0, the sum of the +19 and -19. Now, potassium has got 1 electron in its outer shell. We're going to see that again later on within this topic. But it has 1 in its outer shell, which means it could lose 1 electron or it could gain 7 electrons. Well, it's going to lose 1 electron. That now means it has got 18 electrons left with a total charge of minus 18. But there's been no change in the number of protons, so that's 19 protons with a charge of plus 19. My overall charge, the sum of plus 19 and minus 18, is plus 1. So I take my symbol for potassium, which is K, and I put my plus as a superscript to the right. You'll notice I've not put a 1 there because it's implied that it's 1 because there is no other number. Let's move on to another example. Now, fluorine from the periodic table has 9 protons, which means it has 9 electrons, and that's a total charge of plus 9 from the protons, total charge of minus 9 from the electrons, an overall charge in the atom of 0. Fluorine has an electron configuration of 2, 7. That means it could lose 7 electrons or gain 1 electron. The easiest way to get a full outer shell is to gain 1 electron. Now, that means it's now got 10 electrons, not 9, with a total charge of minus 10. But I still have 9 protons, with a total charge of plus 9. So my overall charge here is going to be the sum of the minus 10 and the plus 9, taking me to minus 1. And again, I write that out with my symbol F, and it's a minus charge, so I put that one on. Now we're going to try to demystify this a little bit and make it more straightforward. Have a go at the tasks here, and then we will review. So the group number is found on the periodic table. Group 1 is lithium, sodium, potassium, etc. Beryllium and magnesium are in group 2. Oxygen and sulfur, group 6. Fluorine and chlorine, group 7. What's really important here is to make the link between this column and the next column, the number of electrons in the outer shell. They are the same. Group 1 have 1 electron in the outer shell. Group 4 have 4 electrons in the outer shell. Group 5 have 5 electrons. Group 2 have 2 electrons in the outer shell. Now, we spoke in the previous examples about losing or gaining electrons to get a full outer shell. All of group 1 will lose 1 electron to get a full outer shell, the easiest way. All of group 2 would lose 2 electrons to get a full outer shell. But by the time we move down to group 6, it would be easier for them to gain 2 electrons. And for group 7, that would be easier to gain 1 electron. Now, we went through in a very drawn out way on the previous examples, but if you lose 1 electron, which is everything in group 1, they will form an ion with a charge of plus 1. So group 1 metals form ions with a charge of plus 1. Group 2 metals lose 2 electrons to form an ion with a charge of plus 2. Group 6 will gain 2 electrons. They will always form ions with a charge of minus 2. Group 7 will always gain 1 electron, forming an ion with a charge of minus 1. And if we take a look through these questions at the bottom, we can see very clearly the group number is equal to the number of electrons in the outer shell. And then these questions are sort of answered together here. But if electrons are lost, we end up with a positive ion. If electrons are gained, we end up with a negative ion. But the number of electrons lost or gained is the size or the magnitude of the charge. Group 2, lose 2, plus 2. Group 6, gain 2, minus 2. Let's move on. Got another activity here. A few questions for you to work on for isotopes. And we have got, where in an atom do you find the neutrons? Well, we find them in the nucleus with the protons. Remember, the electrons are outside the nucleus, orbiting that central nucleus. What is the relative mass of a neutron? This is from the table that you have to remember. It has a relative mass of 1. And how do you work out the number of neutrons in an atom? Well, atomic number is number of protons. Mass number is number of protons and neutrons. So to work out my number of neutrons, I will do mass number, the larger of the numbers, take away atomic number, the smaller of the numbers. For number 4, we need to decide which of these best describes an isotope, and we will revisit isotopes as we carry on through the course. What's different about isotopes of the same element is the number of neutrons. They've got the same number of protons, same number of electrons, different number of neutrons. And number 5 helps us to illustrate that. We have got here chlorine with a mass number of 35 and chlorine with a mass number of 37. In both cases, there are 17 protons, so how many neutrons are there? Well, in the first one, 35 take away 17 means we have 18 neutrons, and in B, we have 37 take away 17 is 20 neutrons. For number 6, isotopes of the same element have the same physical properties. Is that true or is it false? And it is true, they are very similar. There may be very slight differences, but not measurable to us. They also, it's important to point out, have identical chemical properties. And we'll find out more about why as we carry on through the course. For number 7, it's a word matchup. Almost all of the mass of an atom is found in the nucleus. The vast majority, the protons and the neutrons, with a relative mass of 1 in the nucleus, the electrons with a mass almost 2,000 times smaller outside. Vast majority of the mass in the nucleus. We would say an unstable isotope is radioactive, it's prone to break down. And then we have got the number of neutrons and protons gives us the mass number. Moving on to number 8 here, complete the table below with the information. Well, we have got a number of protons. We can see the atomic number is 92. So both of those are 92. We also know that in an atom, the number of protons is equal to the number of electrons. So for the next column, they are 92 as well. For the number of neutrons, we are doing the calculation of mass number, 235, take away atomic number, 92. In the second case, it's mass number 237, take away 92. And that gives us 143 neutrons and 145 neutrons. That takes us to the end of this video. Thank you for listening and goodbye.